you at another video on our channel Euclid Mathematics. Okay, uh, in my today's video, I will explain to you all one of the question from MHT CET Mathematics, which is completely based on probability and distribution chapter. Okay, now let's get start our today's question. I will explain to you all how question look like. Okay, so in our question we have given a die is thrown 4 times. Okay, and we want the probability of getting perfection of our question number 30. Okay, so in our question we have given a die thrown 4 times. Okay, we have die which is thrown 4 times, so number of attempt, okay, we have here 4. That means the value for n, it is a 4 here. Okay, number of attempt we are going to apply for our probability of a set. Okay, so n which is equal to 4 here, and we know that if we throw one die at a time, so we have possible chances to throw one die at a single time, which is a 1, 2, 3, 4, 5, and 6. Okay, we know that a die is having a total 6 side, one upper, one lower, downside, and all side are other side curve sides are 4s. Okay, total 6 sides are there, and every side which written one number which is given 2 digit, 3 digit, 4 digit, like total 6 digits are there. Okay, so if we throw single die, we'll get the probability of that single die is whether 1, 2, 3, 4, 5, and 6. Okay, these are the probability to getting when we throw one die. Okay, now in our question we have given the probability getting perfect square. Okay, so probability of getting perfect square means we want the probability here to this element which is a perfect square. So we know that 1 square is a perfect square, 4 square means which is a perfect, we can write it as the 2 square. Okay, 2 square is a 4 and 1 square is a 1. Okay, so these only these two elements are perfect square. Okay, so if we take the square root for these two elements, we will get the perfect square. So that is, we have only two elements. Okay, we have only two elements, 1 and 4, which is a perfect square. So we got the number of element in our sample space. So this is a sample space. Okay, so what sample space, it says that when we operate some action on our given universal set, then we get the number of element in our sample space. Okay, so here number of element in our sample space, we got the 2 here. Okay, and number of element in our total universal set, how many there? 1, 2, 3, 4, 5, and 6. Total number of element is a 6 here. Okay, so number of element in our probability, so probability it gives us total element, number of element in our sample space divided by number of element in our universal set. So which gives number of element in our sample space is a 2 and number of element in our universal set is a 6. So 2 by 6 is a 1 by 3. Okay, so we got the probability of getting perfect square which is a 1 by 3. Okay, so this is the value for probability P. Okay, 1 by 3. Similarly, we know that if we add two probability like a P plus Q, we'll get the value 1. Okay, so when we add the two probability P and probability of Q, then we'll get the value 1. As we know that probability of a P, then find out the probability of a Q. Okay, so probability of a Q, it says that 1 minus probability of P, because the addition of all probability, it is the value only 1. Okay, so probability of a Q, which is a 1 minus probability of a P. So probability of P is 1 by 3. So then we'll get the value of our probability of Q. So 1 minus 1 by 3. So 3 ones are 3 minus 1, which is a 2 by 3. Okay, so probability of Q is a 2 by 3 and probability of P is a 1 by 3. So we got the two values for probability of P and probability of Q. So why do I found this value P and Q? Okay, so for probability of getting perfect square, at least one throw. Okay, so we want the probability of getting perfect square at least one throw. Okay, so to getting probability of perfect square at least one throw, we have only two possible chances to perfect square, 1 and 4. Okay, so that's why we want the probability for two elements to getting perfect square. So we have possible probabilities here too. Okay, so probability of P and Q, we got the 1 by 3 and 2 by 3. Okay, so we know that if we have probability of getting perfect square which is bigger than 1. Okay, so how many elements are there? Let me explain. Okay, so we have element 1, 2, 3, 4, 5, and 6. Okay, so probability of getting perfect square which is always coming bigger than 1. Okay, the value for x which is coming always bigger than. Okay, So here is the value for x which is coming bigger than 1. So perfect square, we cannot say 0 or smaller than 0 or negative. We are getting perfect square there, okay? So the perfect square which we are getting, which is always bigger than 1. So 1 square is a 1, 2 square, we cannot write the perfect square here, 2, 3, but 4 it is also there, okay? So probability of getting perfect square, we always write it as the value for x which is coming bigger than 1, okay? Not smaller than 1. So, but up to what? Up to the 6, okay? But let's define by using our given data, that how we can define, okay? So probability of x which is getting bigger than 1, which is equal to 1 minus probability of x which is equal to 0. So we do not have x which is equal to 0, okay, in our universal set. So we have to subtract total, and we know that addition of all probability is 1, okay? So if we subtract that element we do not have in our set, we will get the remaining element from our set, okay? Okay, probability of remaining element from our set. So 1 minus probability of x is a 0. X is a 0. That means we do not have that element. So that's why we have to subtract it from our element set. Then probability of a set, then we'll get the leftover element. So 1 minus. So when we have probability of a x which is equal to r, okay, probability of x which is equal to r, then we write as a NCR. This is the standard formula we use for finding probability, PR and Q raised to n, okay? And we know that probability we have to remove x is a 0. That means r which is equal to 0 here, and n which is equal to total number of we have here attempts 4, okay? So total number of attempts 4 here. So substitute all these values in our standard result. So NCR, so 4C0 p raised to r, p is a 1 by 3, 1 by 3 raised to r means 1 by 3 raised to 0, and q raised to n, so 2 by 3 raised to n means 4 here, okay? So find out this value. So 1 as it is, 4C0. So NCR, we have to use the standard result for NCR, which is a n factorial upon r factorial into n minus r factorial, okay? This is the NCR, and also we have NPR too, okay? But we have to apply NCR here, okay? So NCR, okay, so how do we have NC0? 4C0, okay? 4C0 can be written as 4 factorial upon 0 factorial into 4 minus 0 factorial. So 0 factorial is always 1. So 4 factorial numerator remains same. 0 factorial 1, 4 minus 0, 4 factorial, okay? 4 factorial upon 4 factorial, it is 1. So the value for 4C0, it comes 1. Any number to the power 0, it comes 1. So find out the power 4 for this bracket only. So 2 to the power 4, 2 to the 4 to the 8 to the 16. So 2 to the power 4 is a 16 and 3 to the power 4 is 81, okay? Now let's find out the value. 81, 1 is 81 minus 16 by 81. So 65 by 81, okay? So the probability of getting perfect square in at least one throw, by using our example, we got the probability of getting at least in one throw, okay? Perfect square of at least in one throw. So which is a 65 by 81, okay? So this is the quite easy question, which is solely depend on probability and probability distribution chapter, okay? I hope so you all have understood this example with how to figure it out only the value for probability of getting perfect square, okay? So it is quite easy solution that we need to know what we have given and what we have to apply, okay? So I hope so you all have understood my today's solution. It is quite bit easier, okay? Nothing is difficult there. We just need to apply 2 to 3 results. So thank you everyone. Thank you for my today's lecture.